Hi, my name is Angel Huerta, and today I'm going to be graphing log functions. Here's my problem. The first step you want to do is find your asymptote. Your asymptote is normally found in the parentheses. However, in this situation, we have no parentheses. So our asymptote becomes 0. The next step you want to do is make your x plus 4 equal to 1. In this situation, as I said, we don't have any parentheses, so our x is equal to 1. The next step you want to do after you have your first point is to plug it back into the original equation. This would be log base 5 to the first plus 4. Now, log of 1 base 5 is equal to 0. And the 4, which is on the outside, is what you add last. So you got 0 plus 4, and that equals 4. So the first point is 1, 4. Now the next step to find your next point's x, is to make x plus 4 is equal to 5 being the base. So in this situation, again, we have no parentheses, so the 5 becomes the x. Now, after we get our first x, we plug it back into the original equation. Just log of base 5 with 5 plus 4. This right here is equal to 1. Plus 4 is equal to 5. So this is the second point. And now we plug in our points. So we have 1 is right here, and we go up 4 times. And then we have 5, which is around here, and we go up 5 times. And now it should be like that. And this is the first example. For the next example, we have negative log base 3 parentheses x minus 4. The first thing you want to do is get the asymptote. Now, to get the asymptote, you have to make x minus 4 equal to 0. This problem is different because this time we have parentheses. Now back to the asymptote. Once you make it x minus 4 equal to 0, to get it, you add 4, x is equal to 4. Our asymptote is now 4, so now we make a dashed line on the 4. After we get our asymptote, we make it x minus 4 equals to 1. And we use the original equation of the parentheses to get this. Now again, we add 4, x is equal to 5. So this is our first point. After we get our 5, we plug it back into the original equation. So then we get negative log base 3 parentheses 5, which is substituting the x, 5 minus 4. So now we break it down step by step. So 5 minus 4 is 1. So we have 1. So we have negative log base 3, 1. 3 log of 1 base 3 is equal to 0. So we have 0, and then we multiply from the front because we have a negative in front of the log. So now we have 0 times negative 1. This is equal to 0. Now our first point is 0. Our first point is 5, 0. So we can go to the 5, and it's 5 to the right and nothing up or down. So boom. Now for the next step, we use the same original equation with the x minus 4, and this time we make it equal to the base. The base here is 3. So now we have x minus 4 is equal to 3. We add 4. We want to get the x by itself. We have x is equal to 7. That's already our first point. Our next step is to plug in the 7 back into the original equation. So we have negative log base 3 parentheses 7, which substitutes the x, minus 4. 7 minus 4 is 3. So now we have log base 3 of 3. This is equal to 1. So now after we get our 1, we plug it and we multiply back into the beginning of the log, which is negative. So the negative 1 times 1, and that equals negative 1. So we have 7 and negative 1. After you get your final y, you have 7, negative 1. So you locate the 7 on the x-axis. It should be over here. And then minus 1, you go down once. And then it should be something like that. And it goes on forever. These are our points in this example. Thank you for learning with me, and this is graphing log functions.